50 years ago, NASA was on the precipice of mankind's most historic small steps.
EGS Program Chief Engineer, verifying no constraints to launch.
3, 2, 1, and liftoff.
Welcome to space.
Today, we take you inside the control room and onto the ocean during the Apollo 11 mission. We're taking a look back at the work done here on Earth to ensure our heroic astronauts succeeded on mankind's most daring adventure. In a few minutes, we'll hear from Milt Heflin and Melissa Jones on oceanic recovery activities. But first up, we have Bob Sieck. He was one of the engineers on console in the Launch Control Center for Apollo 11 and went on to serve as the Space Shuttle launch director in the 80s and 90s. I am now in the booth with Bob Sieck. Bob, thanks for joining me.
Pleasure to be here and to continue the acknowledgement of the Apollo program and the accomplishments.
Yeah, so obviously we brought you in for a very special reason because you have a very long history with NASA and the space program. So I wanted to let you just kind of give us a really quick kind of flyby of your career, if you would.
Well, okay, so graduated from college with electrical engineering degree, 1960. We had just invented transistors. A chip was still something you carved off a block of wood. And so 3 years active duty in the military, and 63 came down here to Florida to make it my home and be part of the great adventure. I got on with, after a year with contractors, I got on with NASA in 1964, journeyman engineer, Gemini spacecraft, responsible for the biomedical instrumentation that the astronauts had. We didn't know much about the effects of space on the body back then, so they were heavily instrumented, best way to put it, just like the spacecraft and the rocket. Lots of instruments on the astronauts to see how the body reacted to all the rigors of spaceflight. Did that through Gemini and Apollo. I was a test team, spacecraft testing integration engineer, which meant you were like a technical test conductor for the tests on the Lunar module and the command service module, and held that responsibility all through Apollo. Got in on the ground floor of the shuttle program with essentially the same responsibility. And did a couple of years and got promoted to launch director in 83, 84. Had about a dozen missions then, and was then elevated, if that's the term, to the director of shuttle operations at the Cape. Challenger happened, a lot of realignment and changing the organization, obviously. And after Challenger, I successfully lobbied to go back to being launch director. I felt that was my strongest suit, so to speak, to help with the return to flight effort and the continuation of the program, and enjoyed that for a number of years, a total of 50-some missions that I'm thankful there was a landing for all of those.
Yeah.
And then was again promoted to the director of shuttle operations to handle the transition to more the responsibility to the contractor and the new contractor at the time. Retired in 99. Still connected with the people in the business through some NASA advisory panels.
Yeah, and we always love hearing from you and having you back. We could fill probably days with all of the stories and kind of the wisdom that you have to share on space, but we want to kind of dwell on the 60s. So going back to 61, Alan Shepard is flying on a suborbital flight into space. Do you remember this moment?
Yes, I do. And the fact that we did it was, regardless of what the Russians had already done, the fact that we did it, and first step, literally, a lot of people think of the lunar landing, first step on the moon. I think of the first step as Alan Shepard going up. And then maybe in hindsight, the first step was the Russians putting Sputnik up, that kind of ignited our resolve to do something about this in sort of a competitive way at first. And thankfully, the visionaries in Washington saw to that, and we were ended with, that ended with the challenge of putting a man on the moon and returning him safely. Never want to forget that part.
Yeah.
By the
Half the
Kennedy
job.
by the Kennedy administration and starting that great adventure.
And what's that like for you personally? Because at this point, I think you said you're finishing up college, Sputnik's flying, we're getting Alan Shepard off the ground. Is NASA like this fierce kind of wonderful thing that's unattainable, or is it like, let's be America, let's go do this?
That's it. I think it's the latter. It was NASA was obviously given the baton to do this, the responsibility, and the sense was that there was commitment behind that that task or that resolve or resolution, whatever you want to call it in the political environment, and which was important. So I said, well, I want to be at the front end of this adventure.
Yeah.
Obviously, contractors were hiring also, but it was obvious to me it's a government responsibility. So I'm going to go with the government team and see what I can do to be part of it.
And so as we kind of fast forward a few years, how did you end up with NASA? Was this just like another job you were applying for, or was this somehow a special kind of opportunity?
Oh, I looked at it as an opportunity for sure. I took it to heart that this was now a resolve that our nation had put forward, and decided to accept it. So I didn't look at it as just a job. It was kind of like I'm on the mission. Our government's on a mission, our country's on a mission. So I'm going to be part of the team that accepts a challenge and the responsibility of doing the things that need to be done, as Kennedy said, not because they're easy, but because they're hard.
Yeah. Do you think that everyone kind of came in with that team mentality? Is it something where you feel a part of something bigger than yourself?
I would say yes. The most of us that worked in the early years of the space program had spent time in the military.
Okay.
Mandatory draft back then. So
not even just the astronauts, but like the engineers on the floor.
Right. Oh yeah. I would sit at the console next to people that sat in foxholes in Korea or flew B-17s in World War II, and this is we felt, and I think we were looked at as we're a national resource on a government mission here. We're not wearing uniforms anymore like most of us did.
Wow.
But we understand responsibility and accountability, and we've been charged that this is our mission, and so we took it seriously. And of course proceeded accordingly. But we knew there was a lot of attention to what we were doing. It would be a very visible thing, but most of us didn't look at that being the big deal, so to speak. Where what was the big deal was we're responsible for accomplishing this as an individual and as a member of the team, and we're going to get it done.
Do you feel like there's an emotional element to it? And kind of the thought behind that question is thinking about I think my tendency is to think of the military as being very like objective and focused, and we execute. That's what we do. Do you feel like that's really similar to how NASA was operating, or was there a more emotional component to it that kind of was like this feeling and that commitment in a way beyond just
Well, I think it was a combination of both. Obviously, the discipline, responsibility, accountability thing factored into it, but also I remember getting the briefings from the NASA managers when us journeymen first came on board. Was that okay? Now you're responsible for this task. And maybe this set of hardware has these boundary conditions and whatever, and this is your system, and you're going to interact with that system, technical stuff.
Sure.
But the other part of it was the message that came loud and clear was, now, in addition to that responsibility, this is all about the crew and the mission. Number one priority is the crew and the mission. We talk about getting off the ground with a rocket. Yeah, you can cheer that, but it's all about getting these astronauts through their mission, successfully accomplished, landing them, and continuing on with the program. So the emphasis was always on you're responsible for their safety. This is your system. But if you get in a fuzzy area about responsibilities, never forget the number one priority. It's the crew and their mission.
How does that impact you and the people around you when we lose the crew of Apollo 1 then? Because obviously, like, that's got to be hard.
It is hard. It is tough. The initial feeling is we failed. And the challenge of that is getting over the first and foremost. First, there's a shock and the grief and the guilt. What went wrong? What did we do wrong? What did I do wrong as a member of the team, if anything? And then you get into that aspect of, okay, technically, what happened here? What did we do? And then that gets broader into, is there cultural issues here? Is it, what went wrong there? Then you get on with fixing everything. And you can take this to a level lower. When you made mistakes as a journeyman engineer, and we did, we're doing stuff for the first time, and we're developing the hardware for the first time, the procedures to test it. And the approach of management was, well, okay, Bobby in this case, assume, okay, you made a mistake, screwed up, tell it like it is. Now, you won't make that mistake anymore as a journeyman engineer, but the fella coming in tomorrow or the one that's on second shift or whatever, coming in, they're going to potentially do the same thing because you're a responsible person, and this was not a irresponsible act on your part. So what did we management, speaking from their point, what did we do to not set you up to succeed, if that makes difference? Is it the training we gave you? Is it the tools? Is it the procedures? Because that's management's responsibility to set you people doing this work up to be successful and to develop a high quality product, whatever it is. So let's talk about that, understand the root cause, and get on with what we're chartered to do. It was a great environment to work in, really.
Was there ever a sense that you felt like it was too much? Like the pace was too much, the risk was too much, like it wasn't going to happen?
The short answer is no. We were confident that we were going to make progress, and we saw that. After each mission, when things went well, there was always things in the early missions that didn't go well, but there was enough progress that no, we're continuing on. We're going to get this done, and the work was it was an incredible lot of fun. You could, in fact, you will hear from a number of the workers that never felt like they really worked.
Okay.
At the Space Center, they had it was, oh boy, I got second shift tomorrow, and we're running this test and whatever. So I'm gonna work overtime today to brush up on the procedures, so I know that when I come in here tomorrow, I'll put on my headset and hook things up that I'm ready to hit the ground running. And of course that drug into long days, long nights, long weeks, and long months. I always characterize the whole effort of getting to the moon as in my case, a 7-year marathon.
Yeah, man, that's a good way to put it. So Apollo 8, are you in the control room for flying the first humans on a Saturn V?
Yes, that was my first manned Apollo mission, and I was somewhat surprised that it was only 3 months after Apollo 7 when we flew the astronauts for the first time in an Apollo capsule on a smaller Saturn rocket. And the previous Saturn V launch with an unmanned rocket, which had been sometime months before that, was not all that successful. Okay. But then there was enough confidence in where we were in our development and and acceptance of this new system and confidence in it that we can go ahead and commit to put 3 astronauts on top of it and go around the moon after what had happened only just a few years before with Apollo 1. And since then, other than those couple of unmanned Saturn V launches and another one on the Saturn 1, we committed to put our 3 astronauts in a spacecraft and send them to the moon. Yeah.
So we see Apollo 8, 9, and 10 go, for all intents and purposes, pretty well. We're getting ready for Apollo 11. Is this different? Does it feel different from a processing perspective?
I think it did not. It was the process of getting it ready was the same as the previous ones, and it was well, and as we looked at it as where we were in the systems. Okay, we accomplished what we had to on this one. Apollo 8, Apollo 9 got this done. It was in Earth orbit. Okay, Apollo 10 got this done. Now it's in lunar orbit. So the next step is let that lunar module go all the way down there, and let the guys accomplish the objective. And my take on schedule pressure and that sort of thing was it was kind of coincidental that it happened when it did.
Coincidental?
Really? Yeah, because it just did. It ended up playing out that way. But we followed the progression of events. We made some modifications along the way as we found problems and fixed them and developed more confidence in the system, and it ended up. But the approach again always from our management was, hey, you just do the job right, accomplish all the requirements and objectives, and then you look up at the clock or the calendar in this case and say, okay, now we're ready for the next step. In that case, the next step was Apollo 11 and that first step.
So for the launch of Apollo 11, where are you and kind of what are you doing during this time?
Okay, so my primary assignment is Apollo 12. I'd worked Apollo 10,
Okay.
and then we jumped, and we always had at least 2 missions in flow down here. We
Okay.
had the hardware for that, which was a lot of hardware.
Yeah.
4 stages of the rocket.
Yeah.
2 payloads, the spacecraft, the lunar module, command service module, and all the stuff that hooked them together. Most important payload, of course, being the flight crew.
Sure.
So we kind of cycled back and forth, and so I was on the even-numbered missions in terms of the campaign of the launch count itself. When our hardware was in the operations and checkout building, we moved back and forth to different spacecraft doing particular tests, but depending on our expertise. But when it came to Apollo 11, the primary launch team guy for my position was in the control center in the operations and checkout building. If we were not part of the primary launch team process, if we needed to come in as a backup or scrub the next day type thing, you had an assignment. But I was not in the control room. In fact, all of us that were not part of that were advised to stay home and take some compensatory time, annual leave or whatever, and be a spectator. Which and therefore to not add to the huge traffic jam, which occurred every Apollo mission, by the way, but it was more so because this one was Apollo 11. But that was kind of lost on us. Apollo 10, which we just finished, was just as important, and Apollo 12 will be just as important. This is the next one in the queue, and they're just going to do more on their mission than we did the previous, which had been the legacy up to now. So I got to be a spectator. I got to watch with my wife and toddler from Titusville, where I lived, which was the first one I was able to watch, by the way. All the rest of them I had been in the control room and watching with my little 8-inch black and white television set. I couldn't wait to get home to watch the replays on my 18-inch black and white TV set.
So is that really the life of that control room engineer, of just your job is to watch your 8-inch screen?
That's it, and handle the discrepancies and anomalies that come up as they often did back then. Take over the process of sorting out whether this isn't going well. Is it the procedures? Is it the hardware? It was seldom the software because we didn't have any software back then. Or the requirements were asking us this hardware to do too much because it really can't accomplish those specifications in that environment. But that was my primary job as a test engineer for the command service module spacecraft.
And did you have any sort of function once liftoff happened? Were you guys involved with the actual landing operations or the moonwalks?
No, once it was tower clear, literally, our next responsibility came in as participants in the recovery. But we had a control room active on call in the event of an anomaly or somebody needed information from the experience of the hardware and the testing at the Cape. We were there to respond to that. to that, yes. And of course, that happened on Apollo 13.
Sure. So I'm assuming that you would have just been one of the 600 million people worldwide getting to watch on television. Is that
exactly?
Is that true?
Yes, I still remember on the grainy black and white TV set the landing process in the afternoon. And of course, that night I made it mandatory. The kids weren't that old yet, but it was required that they be in the living room with Mom and I watching the first step.
That seems like a good way to spend an evening.
Yeah, well, it was for me. You know, there's kind of an anxiety because we know as engineers, you think about all the things that could go wrong. So every time something went right, it was kind of one of these, yeah, okay, feel good, yeah, okay, yeah, that worked, yeah, and there's another good, type of thing. So we're probably more into it than the average spectator, if that makes sense. But the way I look at it, and the way everybody else did too. Hey, we're all part of a team here to accomplish this. You don't have to be doing the highly visible thing on launch day to be an important member of the team. You think about it. Somebody that does the final recovery parachute rigging, and that happened in the ONC building months before launch, and then they stamp a procedure that says, I did this correctly, and I'm certifying it's done. It was done right. Well, they just gave a go for launch, just as important as the one that somebody does in the control room with a headset on at T-minus whatever minutes and all the tension and visibility that got. So, and the important thing is that person, using that example, that parachute rigging, knew that what they were doing was important, and that it had to work, and that's what made every member of the team feel like, I'm part of something that's much bigger than me, because people are giving those goes for launch all around the center and some places elsewhere around the program, just like I am right now. So they should naturally celebrate and take pride in that first step, so to speak.
Did you find a similar mentality with your coworkers at the time? Just kind of that like, at least a moment to kind of just, we did it. Like, yeah. we accomplished the task.
Oh yeah, absolutely. It's and of course that, we're considered to be, well, you're the launch team, you get it off the ground, and then after that your responsibility is over and that sort of thing. But the way we looked at it is the way I explained earlier, but with the chief engineer said, no, it's not done until the crew gets back on Earth, and then you can really celebrate.
Sure. So we're now 5 decades removed from that historic moment, those historic moments. What, as you reflect back, what's your takeaway? Like, how do you process that today?
Well, it's I think it's a cause. It's a reason to be kind of celebratory over the accomplishment, and from a personal standpoint, we felt, okay, we're on a mission with the work we do every day or night we go to work. It's again, I'm looked upon by the public and the administration at that time as I'm on a mission that the country has decided to embark upon. So what I do is important, and the fact that Apollo 11 happened to be the one where the mission planner said, okay, now is the one we're ready to actually go out on the moon, was not, from the standpoint of looking at it as a big deal, was not a big deal. It was important. Now, in hindsight, 50 years later, I say, well, okay, it was a big deal, but we never got, and I feel I'm speaking from the others, got caught up at the time in that euphoria that, oh boy, this one's Apollo 11, this one's Apollo 11. I said, well, I know it's Apollo 11, but Apollo 12, you're only as good as your next mission.
Sure.
So my focus is here. Yeah, that's good and that's important, and we got it done. Yay! Yeah. Now, don't lose sight of the ball.
Yeah. Any words of wisdom for those that are working on the next giant leap for mankind?
Well, never lose sight of the number one priority. That's first and foremost, which is the crew and their mission and accomplishing that safely. And then you can enjoy the mission success. Be patient. Never get caught up in the rush to meet a milestone or worry about the cost. And that was another one of the things that made Apollo successful. As journeyman engineers, we said, you don't worry about schedules. You need a realistic schedule, and if this is not realistic, you tell us, and don't worry about what it costs, because we're going to the moon. This is a national resolve. So don't make a decision based on worrying about what this is going to cost. If this is the right way to go, this is the way you do it. And you have to approach that the same way if you're working don't compromise what will work and is safe just because you're worried about what it'll cost in terms of schedule or the bucks. And and enjoy what you're doing. Be a member of the team. I think that's more difficult nowadays than it was then. We didn't have the technology where you could communicate by emails and cell phones. If you wanted to talk to somebody, you usually got up and went over and talked to that person, because there weren't that many involved in the process down here, and we didn't have the communications capabilities we have today. So you could, and communication is important in a team effort, and you build more cohesiveness as you get together, sit down across the table, or in big meetings. And we had a lot of meetings. Because we didn't have the other way to communicate. So everybody had a feel for everyone else who was a participant and their responsibilities, and you wanted them to be successful just like you wanted to be successful, because if they weren't set up to succeed, then nobody succeeds, if that makes sense. And so be a team player for sure. Do your homework, and never lose sight of the primary objective. Apollo was hard because even though we had a lot of people involved, technology didn't streamline things like it does today. It wasn't there, so there was a lot of human face-to-face interface. You spent long hours, long weeks. It was hard on families. Yeah, I got to make that point. The term I use, only the strong survived, and credit those families, particularly the spouses of the workers, and most of us were guys back then, that did keep the family unit together. And I think another item to consider is, if we're comparing back to the 60s, we are a more risk-adverse society today than we were back then. Now, that could be the view of a guy getting old and cynical, but we are, and there's a difference between measuring and assessing a risk and gambling. Yeah. And so you don't want to get in the gamble part of it if you're if particularly when human lives are involved. You don't. But on the other hand, don't be afraid to accept the risk after you've looked at every aspect of it technically and the other side effects of it, and decide that and have others look at it too, to accept the risk. If the goal is worth the risk, stop worrying about it and go do it. Cool. Bob, it's a pleasure to have you. Thanks for stopping by. All right. Well, enjoyed it. Yeah, and look forward to the next piece of the great adventure, which has already started because we've been given a goal, right? Absolutely. We tracked down Milt Heflin, one of the guys who worked recovery operations in the Pacific Ocean when Apollo 11 returned from the moon. He was actually pretty easy to find, as he is currently lending his expertise to the team developing Orion Recovery procedures. And he brought along one of his colleagues, actually the NASA Landing and Recovery Director for Exploration Ground Systems, Melissa Jones. All right, I'm in the booth now with Milt Heflin and Melissa Jones. Thank you both for joining me today.
Thanks for having us.
You bet. So I want to kind of go back a little bit. So Milt, you actually worked recovery for the Apollo program back in the 60s, correct?
I did. I was on the primary recovery ship for the splashdowns of 8 Apollo missions.
Man, so let's go back a little bit further than that. What's it like kind of growing up? Because when you were growing up, there were no astronauts.
Correct.
So what's that like to kind of get into the world of NASA and get a job working on plucking astronauts out of the ocean?
Well, I had not planned to come to work for NASA. I was going to continue school, Oklahoma State University, work on my master's. And but a good friend of mine who had relatives in Houston came down during spring break of our senior year, and he got hired. He just showed up on site, and they had tables set up, and he came back and said they're looking for people. So that's how I started, how I got involved. So I didn't have a clue what I was getting into when I started, except I knew I would be working associated with landing and recovery for Apollo. And I don't think I ever worried about the fact that I didn't know what the hell I'm doing, but I'm learning it as I go along, and there was plenty of room to do that.
Now, is that how life was at NASA in the 60s? I mean, that's what I hear, is that it's kind of like people got hired and they were like, we think we're going to do this, go figure it out.
Oh, we had free reign, basically. I mean, that's what I think was so beautiful about that period of time, is that I could go over a number of tests that I were involved in during those days where there was no test review board. Some cases there were no procedures other than we wanted to go do this and try that, and if that didn't work and it was a piece of hardware or something, take it back to the shop, go grind on it, bring it back out, put it on the capsule, run a test and see if it worked. And then when you're done, I don't remember everything followed up with a drawing either.
So, were you an engineer? Were you a technician? Like, how would you have described yourself?
I was a recovery engineer, degree in physics and math, but I was categorized as a recovery engineer. And I worked in a section that was system suitability section, a weird name, but basically our job was to take the hardware that was being built to recover the Apollo and test its suitability for doing that job. So it was called the system suitability section. So everything to connect with splashdown and recovery, we got involved with some way and either tested it. But we tested a lot at water tank there at the Johnson Space Center, Manned Spacecraft Center back then, and then we were close to the Gulf of Mexico, so we would go out. We had our own boat that we used to take the capsules out into the Galveston Bay or out in the Gulf and do tests.
And what's the culture like at the Johnson Space Center or NASA back in the 60s? Is there a typical day? Is this kind of like just, hey, we know what the ultimate goal is and just whatever it takes to get it done?
Yes. The last thing you said, Josh, I think is exactly what that was about. It was, we had an idea, and we were free to just go grab a handful of technicians, folks who would be involved in setting up a test, and a lot of times just making it up as we went along. But we had a concept that we wanted to get to, and we weren't exactly clear how we're going to do that, but we didn't spend a lot of time thinking about it other than just going and starting to do it and do it as we went along.
Did you feel a sense of pressure or a sense of, I guess that's the question. Like, was there pressure that we had to kind of be done by the end of '69?
I don't think that I don't think I ever thought in terms of pressure. I was learning the trade basically, and I had a mentor, and so I just basically would follow him around, and learn on how things were being done back in that time frame. And we didn't spend a lot of time thinking about. I think spending a lot of time worrying about the future more than what we had to do today to do what needed to be done that day or that week and get it done. That's just what we did.
So Melissa, certainly not to leave you out of the conversation, but definitely kind of setting a stage there. Mm-hmm. As you've worked with Milt and as you've spent time kind of working on recovery operations for Orion, we're doing testing now, getting ready for the future. How are the stories that you hear, how do you relate to those with our culture today?
It's so funny that you would ask that, because first I'd say that having Milt on the team is really like a breath of fresh air a lot of the time. He's very encouraging, and the team loves him and to hear his stories and that kind of stuff. And he will frequently say that this is a magnitude harder than what they tried to do in Apollo. And we have a lot more people on the team, I think, who have their fingers in discussions and a lot more paperwork and traceability and the types of things that I think maybe he had the freedom to do differently. One of the examples right now, I would say, we're working on a strobe objective. We're trying to, there's a strobe that goes on the capsule so that you can see it in the event of an emergency landing or if you land at night.
Okay.
And I think, Milt, you had a strobe as well. And we're trying to develop the test plan, understand all the parameters, and get all the permissions. And Milt's told me that they just stood on top of the roof at JSC and turned the light, make sure they could see the light from Galveston Bay. And here we are. We're trying to put all these procedures and plans and timelines and schedules and stuff together to do a 45-minute test. So I would say it's definitely different than some of the things that Milt was able to enact in Apollo with the culture that they had back then.
So, and this is a question for either of you, how would I summarize that difference? Is it a nature of kind of working towards repeatability? Is it working towards precision? Like, what's a way to classify that?
Why it's so different?
Yeah, like what's the difference? Like, if you could summarize it, what's the difference?
I don't...
Melissa, that's kind of tough. I think, well, as NASA grew up, right or wrong, and I hard to judge, but various processes changed, requirements changed. We did a lot of things that I would tell you right now, and because I was involved in some, we did a number of things that we were not safe when we did them. I mean, when we were doing some work, we were not really safe. And we were fortunate, very fortunate a number of times. Well, throughout the period of time from back then and now, we've all been through tragedies in this program.
Right.
And so along the way, new requirements come into play, and there's a greater attempt to do things smartly and safely at the same time. And that sometimes is a real hard thing to do.
It's all in a positive effort to, have proper traceability, proper accountability, proper visibility to those who are accepting risk for the certain tests that we're doing or the certain flights that we're doing. And so I think that it's all with the right idea. I don't believe when Apollo started, you guys had a safety and mission assurance organization, and I think we've grown into that culture as we've had some lessons learned and some tragedies. And so I think it's an effort to kind of bring it all back together and make sure that everyone is comfortable with what we're doing based on some lessons learned we've had. But I do think that sometimes you can get wrapped up in too many boards to make a simple decision. So there's probably a balance there that we could probably strike a little bit better with some work and analysis on our processes.
The overhead that I've seen that Melissa talks about, they get through it pretty doggone good. I mean, it's there. And with her leadership and others, I mean, they get through these things. And sometimes it's difficult to hear all that going on, but it's not like I don't want to say it slows down what you're really trying to do. But it is a very delicate balance between that, and that's what I've seen. Yeah. Melissa and other leaders in the landing and recovery. I mean, I can sense that that's what they're exactly trying to do, is do what really needs to be done, and recognizing what's involved.
So, Milt, you talk about kind of the safety differences. So back in the '60s, was it a situation where like you recognized, hey, this is not the safest way to do this, but we have to go? we've got to move. Is that how this is, or is it more in hindsight you're saying like, wow, like we got away with some crazy stuff that we didn't realize at the time?
Well, probably a little bit of all of what you said. I can think of some things that I was involved in relative to testing, and it's like we got what we needed to get done, and in retrospect, not so much then, but years later, when you think about that, you're thinking, well, that was, we were lucky that we didn't really injure somebody when we were doing that, and I mean, that's just the way it was.
And as we kind of think about this idea of safety, and we kind of mentioned the idea of crew losses, back in the 60s, obviously there was this race against Russia. We lost the Apollo 1 crew very tragically. How did that really impact the progress in the process for you guys? And then kind of, Melissa, as a follow-up for you, how are you learning from kind of that perspective from the Apollo generation?
Well, so going back to Apollo 1 in the fire, it is remarkable what we did in this nation after that. I mean, you talk about gutsy work going on.
Yeah.
Apollo 7, the first manned flight, and the gutsiest thing this nation has ever done in manned space flight, in my opinion, is Apollo 8, the second Apollo mission, where we put that capsule on top of the big Saturn V, and we went to the moon. We didn't land on the moon, but we went to the moon. After one man test flight of Apollo, we did that. And that, I think, is what really allowed us to say, once Apollo 8 was done, it was like we're rocking and rolling here. We know what we need to do. We set up the management structure back then, set up the right kind of things that had to be done on Apollo 9, Apollo 10, leading up to Apollo 11. Stepping stones that all worked. And Josh, I might have got off the subject of your question, so I
No, that's all right. Yeah. No, it's good stuff, because again, I think it's coming back to that reality of, hey, how do we like honor sacrifice and make good decisions for the future? And so, Melissa, again, over to you, kind of asking the question, like, how has the team kind of processed the fact that you're going to go pull astronauts out of the ocean after what is hopefully a very successful flight?
Yeah, so I would say that I think part of your question was how have we changed maybe from Apollo, and how have we learned from the loss that we've had. And I think that we've learned a lot from lessons that Apollo and the Space Shuttle program brought us about incremental testing and risk acceptance and redundancy and tolerance and margins and factors of safety and design standards, and what we feel is acceptable for putting human people in a giant rocket that has, explosives and cryogenics and different things in it, right? So that we can get to space. And so I think, we have learned from every single, not just tragedy, but all of the successes that we've had. We learned from successes that other people like ULA and SpaceX and Boeing have had. Any success in the space industry is success for all of us, and we learn things from that. We are excited. We did go from Apollo to water landings, to Space Shuttle land landings, and now we're back into the water landings. And I would say that, Milt is the only one on the team that really has any experience with that, because those of us who have human spaceflight experience are from the International Space Station program or from Shuttle. So that's one of the reasons why he's so valuable on the team, and he helps us with a lot of the things that Apollo did and their flight rules and their weather conditions and where did they have issues. And so we're all very excited about what we're doing, but we're trying to be very meticulous with our testing, with our procedures, with our safety culture. We work with the Navy again, just like they worked with the Navy, a little bit in a different ship configuration. But there are some similarities to the way that Apollo did recovery to what we're trying to do now.
Milt, were you there when Apollo 11 came back, and did you help get the Eagle out of the water? I guess it wasn't the Eagle, because the Eagle's on the moon.
That's right.
So it was
Columbia was the
Thank you.
Was the command module.
Thank you.
Yeah, for Apollo 11. Well, I had many different jobs back in the Apollo days. At Apollo 11, I met the Hornet, USS Hornet at Pearl Harbor. When the ship got back to Pearl Harbor, I was one of 2 NASA engineers that oversaw the contractor team that safed the command module for air transport back to the United States, back to the continental United States. So for Apollo 11, that's what I did. I was one of the 2 team leaders. We did over about a 48-hour period nonstop. Had the contractor team safe the command module and then loaded up into a 4-engine turboprop cargo carrier. This is back during the Vietnam time, so this is about the only aircraft that we could use that could make the jump from Hawaii over to the West Coast. That aircraft, I guarantee you, Josh, I'm surprised the rivets stayed in that airplane when we flew that thing back over here. That thing shaked, rattled, and rolled the entire time. So I was the NASA guy on board the airplane that went all the way back to Houston with the command module to attach it to the Lunar receiving laboratory for further processing when we were done.
So did you get to see Neil, Buzz, and Michael when they came back?
I saw them being taken off of the ship in the mobile quarantine facility that they had.
Sure.
I saw that happening, and then, but just from down on the deck or down on the dock, seeing them being picked up inside that
cool
that trailer.
That's awesome. So Melissa, what's the plan for you as far as with Orion? Where are you expecting to be located for Orion Recovery?
So we'll be on a ship, a landing platform dock ship off the coast of San Diego. The primary landing location's about 38 to 50 nautical miles off the coast. I specifically will be in the landing area on they call it the CIC Combat.
Combat Information Center.
Combat Information Center on the ship. It's where they run ops on the ship when they have different operations that they run. So that's where I will be, along with public affairs and a few other folks. And we'll have access to the bridge where the captain's at, and we'll have access to the folks who are doing the actual operation in the open water. So we'll be physically located on the ship when we do the recovery.
So have you thought about what it will be like to greet astronauts coming back from the moon someday?
Yes, actually, it's quite mind-blowing to think about, to be perfectly honest. And, what do you say to them? Is it welcome home, something like that?
Yeah.
Knowing that we are there to get them out as quickly as possible and get them to medical so that they, can start to recover from being deconditioned. But yes, it is it's historical. It's a really exciting thing for me to think about.
And Milt, kind of as you worked with the team in your current role, what's the one message that you want to leave to the whole team to kind of help to, whether it be encourage or inspire or support them? What's 5 decades later from Apollo 11 and the 60s where we landed on the moon?
Well, first of all, Melissa made a comment a while ago that a thought came up, and that is, many times as I am participating, and basically I'm tied into conferences from my home, and occasionally we have face-to-face, but many times she doesn't hear from me, and she doesn't hear from me because I don't have anything to offer after that time, because what they're doing makes sense to me. I mean, I mentioned it a while ago. This recovery of this spacecraft out of the water is an order of magnitude, if not 2 orders of magnitude, more difficult than what we did back in Apollo. And it's very simple, because the program some time ago decided they don't want to take mass into orbit that is going to be used at the end of the mission only to pick this thing up. We had a lifting loop on board the Apollo. This spacecraft is probably 10,000 pounds heavier on the water, and it's about 4 feet diameter also. It's bigger, and it's like a cork. It sits on top of the water. And so they had no way to just get we used big old honking aircraft carriers back in those days.
Right.
And with a crane on board the ship, even though we augmented that crane, and it was a extremely simple operation. So it's remarkable how they have. I've watched this develop where you're dragging the Orion capsule mock-up into the well-decked ship. And I mean, it has turned out to be a very elegant way to. It looks weird, but it's a very elegant way to take advantage of physics, and be sure that you're tending this 20-some thousand pound vehicle as you bring it into the well deck. I probably got straight off on something there, but that's.
No, I think it's great. I think that what I hear from you is that whether it's good or bad, the long processes are paying off. That we're doing things really well.
So yeah, and I got away from a part of your question there. The concern that I have, and Melissa knows this, I think, and some of the other key leadership of the team, they've got a big team, and there's a tendency to everybody wants to play on a big team.
Sure.
And not everybody needs to play on
Sure.
a big team. And our team was much smaller. There were the communications during recovery. I've often told her, I said I can recall almost every mission I was on. We gave we told the captain of the ship that the spacecraft was safe on the water, and then he gave the command for them dropping swimmers in the water from the helicopter and starting the process. And the NASA team leaders back then probably didn't say hardly anything, and during that entire hour and a half process to get both the crew and the command module back on the ship. I mean, there was no no-goes. The helicopters, the swimmers, the deck force all knew what to do, when to do it, and how to do it. And there was no reason to quiz them about anything. And we were fortunate. In picking this Apollo up, we never had any serious problems. I should not have said Apollo 9. Apollo 9, we had a winch problem, and we had to use what was called the Tilly. It's a big old crane on board the aircraft carrier that's used to pick up a downed aircraft in the water, pick it up. It's on the flight deck, and so we had to use that crane to get the Apollo 9 command modules back on board, and that was pretty tricky because there's not a good way to tend that thing as it's coming all the way up, 40, 50 some feet.
Awesome. Melissa, any final thoughts?
No, I just not really. We're excited about the direction that the agency's moving in with the Moon to Mars program. Recovery is ready. We have our hardware. We actually are getting ready to move into what we call operations. So we've got hardware that's been verified and validated and meets all of our requirements for how we move the capsule around, making sure that we preserve it so that we can get the data that we need off of it to verify that we can fly crew for the first crewed mission. And so I'm very proud of the team. I do understand Milt's concern about the size of the team. In fact, I think some of it will shrink a little bit now that we're getting our hardware requirements bought off. But we're excited and we're ready.
Awesome. Well,
Yeah,
Milt, we're super proud of you and the accomplishments.
Can I tell you one story?
Yeah.
If you
I
don't
love
mind.
the stories. I love
Milt,
the
fire
stories.
away, man. I'm excited. Here it comes.
I thought about it. So back, I talked about Apollo 8. I need to tell you how part of that happened.
So setting the scene here, this is the Christmas Eve
The
trip around the
Christmas
moon.
Eve, 1968.
Right.
It is at the height of the Vietnam War.
Okay.
Forces are all over out there in the, across the Pacific, and so assets, ships, planes, they're just not. I mean, they're around, but it's not like it took some effort to pull that together. Well, the very first flight director, Chris Kraft, was the lead flight director back in those days, and he was sent. NASA headquarters wanted him to go out to about to Pearl Harbor and meet with Admiral John McCain from that family. So he was the commander in chief of the Pacific at that time, and he was to go out there. Kraft was to go out there and brief him and his team and about what's needed for Apollo 8. And So Chris Kraft went out there and gave the briefing. And this is an example of how this is something that happened back then that I'm not sure happens today collectively in our country to do some great things. What happened back then was that when Kraft got through giving a briefing to an audience of admirals and generals out there in Pearl Harbor, Admiral McCain looked at Kraft and looked at the audience, and he said, "Great briefing. Give this man what he wants." And I don't see a lot of that today when we're trying to do great things, and that's a big difference to me.
Is it just this kind of authority to say, like, this is the right thing?
You betcha.
Whatever it takes, go do it.
You betcha. I mean, that was a good example of it. Give this man what he wants back in that time frame.
Awesome.
And
Well,
I was on the Yorktown, which was the Apollo 8 recovery. That was my first time to be on a splashdown of Apollo 8.
what's that feeling like? You got
Oh,
guys
yeah.
that literally just saw the moon from up close. The
Yes.
first guys ever, right?
Yes, oh, absolutely.
They come back, and you're getting to pull them out of the water.
Yes.
What's that feel like?
Well, when they're safely on board the ship, it really feels good. It really feels good. And I think Borman was on that crew, if I recall. I hope that's right. Once the crew was on board, actually the crew got picked up by helicopter. And that's how we did it back in those days. Then we got the command module on board. It was several hours after the crew had been on board. I'm down there at the command module with the team, and we're safing it and going through and de-stowing stuff and packaging things up or whatever. Next thing I know is there's two hands on my shoulder shaking me, and it was Frank Borman, and just saying, "Looks good, buddy. How we doing?" And that was cool.
Oh man, that's gotta feel special.
You bet, absolutely, absolutely.
Well, Milt, we're appreciative of your efforts in the 60s to help us be successful, and even today, helping us prepare to be successful once again on our moon missions. Melissa, obviously you guys have a big, big task ahead of you. I know that you all are up to the challenge, and we're excited for everything that is to come. So thank you all both for being here.
This team can recover this spacecraft, I guarantee you, and they're going to be able to recover the crew, too.
Thank you. Thank you, Milt. Thanks for having us.
You heard it here first. The team is ready. They are pumped and getting excited for the moon missions coming up in the next few years. I'm Joshua Santora, and that's our show. Thanks for stopping by the Rocket Ranch. And special thanks to our guests, Bob Sieck, Melissa Jones, and Milt Heflin. To learn more about the Apollo 50th anniversary activities, visit nasa.gov. For more on Orion underway recovery, visit nasa.gov/EGS. For all things Orion, visit nasa.gov/Orion. And to learn more about everything going on at the Kennedy Space Center, go to nasa.gov/Kennedy. A special shout out to our producer, John Sackman, our soundmen, Lauren Maythree and Michelle Stone, editor Michelle Stone, and special thanks to Amanda Griffin. And remember, on the Rocket Ranch, even the sky isn't the limit.